Okay, let's talk about powers and exponents. So this says elephants at the National Zoo in Washington, D.C. eat 125 pounds of hay each day. Each elephant weighs more than 10,000 pounds. So use the fact 5 as a factor what? Write a multiplication expression that equals 125. Well, we could write 5 times 5 times 5. That would equal 125. Good. And then using 10 as a factor, write a multiplication expression that equals 10,000. We could do 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. That would equal 10,000. And that's what we're talking about today. An expression like 5,000 like 5 times 5 times 5 with equal factors can be written using an exponent. An exponent tells how many times a number is used as a factor. A number that is expressed using an exponent is called a power. The number that is multiplied is called the base. So 5 times 5 times 5 equals the power 5 with an exponent of 3. So basically your number is the base, or what is next to the exponent is the base, and the exponent is the number written above to the right of the base, and the whole thing is called the power. So this says 5 to the first power would be a factor of just 5. And if you have just a number and no exponent, there's an invisible 1 up there. There's an invisible 1 exponent because it's the same thing. Now, 5 to the second power, or 5 squared, would be 5 times 5. 5 to the third power, or 5 cubed, would be 5 times 5 times 5. And 5 to the fourth power, or 5 to the fourth, as you could say, would be 5 times 5 times 5 times 5. So you can see that all an exponent is how many times you times the base by itself, okay? And any number except 0 raised to the power is defined as 1. So you could see, for example, 2 to the 0 power is 1. 5 to the 0 power is 1. It even works with variables, okay? X to the 0 power could be 1, or is 1, as long as x is not 0. Okay. So write an expression using exponents. So we're not solving anything. We're just writing it with exponents. So we have 4 times 4 times 4 times 4 times 4. We could simply write that as 4 to the fifth power because there's 5 4s. Or negative 8 times negative 8 times negative 8. We could simply write that as negative 8 to the third power because there's 3 of those multiplied to each other. Let's look at this. We could use exponents as well. So in this case, we have y times y times y times y times y times y. Well, there's 6 of those y's. So we simply could just say y to the sixth power. And on b, you could see that we have k plus 2, and it's multiplied together 4 times. So we could simply just put k plus 2 to the fourth power. Now, when you have parentheses and you have an exponent on the outside, everything in the parentheses would be raised to the fourth power, okay? So we have 5 times r times s times s times s times s. What you would do is you would group. So you would group the like together, the like terms together. And in this case, we would just have a 5. We have 2 r's, so that's r to the second power, and we have 4 s's, so that's s to the fourth power. Or simply 5r squared s to the fourth power. So let's take a look. How can we express these using exponents? Again, we're not solving, we're expressing. So there's 1, 2, 3, 4, 5, 6, 7. So it would be 5 to the seventh power. On m's, 1, 2, 3, 4, 5, 6, 7. So that would be m to the seventh power. Okay? So just however many times we're multiplying the same thing times itself, we can use as an exponent. All right, let's look at these two. We have 1, 2. So we'd put z to minus 4, and the whole thing would be raised to the second power. And this one's a little bit different. We have 1, 2, 3 of the negative t's. So we could say negative t raised to the third power, and that didn't look too good, did it? Negative t raised to the third, but we have this 3 over here. So it would be 3 times negative t raised to the third power. So when you have this, the exponent only goes with the base that's in front of it. It would not go with the 3, okay? So we'd have to find this part, then we can multiply times 3 in order to solve. All right, so since the powers represent repeated multiplication, they need to be included in the rules for orders of operation. So first step would be to simplify the expression inside the grouping symbols. Then evaluate the powers, or the exponents. Then do multiplication or division from order from left to right. And then finally do all addition or subtraction in order from left to right. Okay? All right. So it says the playing area for beach volleyball includes the playing court and the free zone. Evaluate each expression to find the area of the playing court and the free zone. A, the playing court is a rectangle with an area of 2 to the 7th square meters. Well, all we have to do is take 2 times 2 7 times, and we would end up with 128, so the court is 128 square meters. And the area of the free zone would be, it says 2 squared times 3 squared times 5. So we simply take 2 times 2, 3 times 3 times 5. That would give us 180 or 180 square meters for the free zone. Okay? All right, so let's take a look at these. Now it says evaluate the expression. So evaluate means kind of like solve the expression. So take it down to its simplest form. So 7 to the third power would be 7 times 7 times 7. That would be 343. Okay? Then we have negative 3 times negative 3 times negative 2 times negative 2 times negative 2. Negative 3 times negative 3 would be positive 9 times negative 2 times negative 2 would be positive 4 times negative 2 is negative 8. And 9 times negative 8 is negative 72. All right. This last one would be 8 times 8 times 6 times 6 times 6. 8 times 8 is 64. And 6 times 6 times 6 is 216. And 216 times 64 would be 13,824. Okay? All right. So now let's look at evaluate algebraic expressions. So to evaluate, you would plug something in. So we have x squared plus y to the third power if x equals 6 and y equals negative 2. So the 6 goes in for the x, so x squared, plus negative 2 goes in for the y, negative 2 cubed. 6 times 6 is 36. Negative 2 to the third power would be negative 8, and 36 minus 8 would be 28. Okay? So let's look at a couple of those. We have g to the 5th. So that would be 3 to the 5th, because g equals 3. So that would be 3 times 3 times 3 times 3 times 3. And that is going to equal 243. Okay? Let's look at number 2. We have h is negative 1 and m is 9. Now again, the base for the exponent is only m, not h. So then I would go negative 1, 9 times 9. Remember, order of operations, the exponents are the powers first, then multiplication. So this would be 81, and so negative 81. Okay? All right. Then we have 5 times h, which is negative 1 to the 4th power, minus 9 squared. So 5 times negative 1 to the 4th would be positive 1, and 9 squared is 81, so that gives me 5 times negative 80, which would give me negative 400. Okay? All right, if you got any questions, let me know. Otherwise, have a great day.